All right, good evening, everybody, or good afternoon, wherever you may be. I'm going to talk about some geometry basics, more specifically just talking about the Pythagorean theorem. There are some things that we generally know about geometry. We had a great conversation yesterday about it. And so I think, today is just an opportunity to kind of go over those things. I'm going to work through a couple of just basic geometry problems using the Pythagorean theorem. And I'm also going to introduce something called special right triangles, which you can discover as you use the Pythagorean theorem, but it's unique situations that we will be discussing and using in their next standard. Okay, so geometry basics is kind of like I said, cover over Pythagorean theorem. So, for example, this is important that C is always the hypotenuse, and we kind of came to that conclusion yesterday. And so, if we have the Pythagorean theorem as our basis here for pretty much all these practice problems, we have a squared plus b squared equals c squared. And so A and B are the legs, and the hypotenuse is opposite to 90 degrees, or the longest side in a way. All right, so if I have 4 squared plus 5 squared equals c squared, that would be 16 plus 25 equals c squared, which would be 41 equals c squared, which in turn, square root, we would get the square root of 41 equals c. Okay, so that was a very quick algebraic technique there. We kind of we got things figured out there. You could definitely figure out the decimal if you like, but you can certainly leave it as square root 41. Okay, so I worked through that problem rather quickly, I know, but I think we're all pretty familiar with the Pythagorean theorem. The next problem I'm going to teach you is, or example I'm going to use, is probably where people make the most mistakes with it. All right, so if we got b squared equals c squared, all right, what people do is they'll say, all right, I know x is the missing piece, so they put that in for c every time. Okay, but in this case, we're given the hypotenuse, which is c, so we have 5 squared plus x squared equals 10 squared. Okay? So this is the important thing. 25 plus x squared equals 100. Oh, not 1,000, 100. Minus 25, and we get x squared equals 75. And we're going to square root this, and we come up with x equals the square root of 75. Now, for the time being here, again, we can type this in a calculator if we wanted to, but I don't necessarily want us to do that right now. What I want you to do is actually put this into simplified form, which simplifies to, let's see, square root 25 times square root 3, which equals 5 square root 3. Okay, so with this problem here, square root 75, so the actual x equals 5 square root 3. Okay, so if we look at this particular problem, we have that problem right here. We have 5, 10, and then we have 5 square root 3 for x. Now, this introduces a good concept for us. It's called special right triangles. We didn't know this at the start, but really what this angle is right here is a 60-degree angle and a 30-degree angle. We know this because this is something called special right triangles. Is that when we see a problem that has 60 degrees, then we assume this is 30 degrees, so on and so forth, we're able to use these ratios to help us out. So say, for example, and I kind of proved it here on this problem, is that 5 is the smaller leg, or opposite 30 degrees. We can take the number, whatever that length of the opposite side of 30 degrees is, we just put square root of 3 next to it, which we did, 5 square root of 3, and then we just double the side opposite of the 30 degrees. Okay, so this is like a little ratio thing, or a little idea here where we can use quick references. We don't necessarily have to use a Pythagorean theorem, and it can also help us when we have limited information, which introduces this next concept. All right, so now that we've kind of got a basis for the Pythagorean theorem, we're able to come up with these things called special right triangles, in which they are 30, 60, 90 triangles, or in this case that I'm about to do is 45, 45, 90 triangles. All right, so if we do this, we see that, okay, this is 45 degrees and 3. Now, if I knew nothing about special right triangles, I would not be able to solve this problem because I need another side in order to use the Pythagorean theorem. But because of this ratio right here, I know that, let me bring it out in the open here. I know because this side is 3, I know the opposite side here is also 3. And then I know that the hypotenuse is going to be 3 square root 2. Okay, we've known this because it's just a simple test that we can do multiple times, but it's kind of like a shorthand for doing the Pythagorean theorem. So if you see that 45, you know that the legs are both equal, and the hypotenuse is 3 square root 2. Okay, so again, this is going to help us when we start to get into the unit circle and stuff. So be paying close attention to that 45, 45, 90 stuff. All right. Next thing is, let's look at number 4 here. We have 60 degrees, and we have, because it's 60 degrees, we know that all the angles inside a triangle equal 180 degrees. That's something we discovered yesterday. And so using the ratios, I know that this side is 5. This is example 4, by the way. I know that this side right here is going to be whatever the side opposite the 30 degrees is going to be that length times square root 3. And so we have 5 square root 3. And then the side opposite, or the hypotenuse of this thing is 2 times the x, which is 10. So without doing any kind of Pythagorean theorem, I'm able to just put this ratio to work, and obviously this is my answer. Okay? So, again, I know I'm going through this rather rapidly, but I think you guys can catch on to it rather quickly. Special right triangles, something you guys have covered in the past. Maybe it didn't seem like it made sense, but now you are older and much wiser. So, example 5. Now let's talk about this one here. This is a little different situation. This looks like a 45. I'm going to redraw that because I don't want it to look like a 45, 90 triangle. Okay, well, that's a bad looking triangle. We'll go with it. All right, so let's say, for example, I tell you this is 8 and obviously 60 degrees. All right, we need to find this, and also we know that that is there. Okay, we also know that 8 is equal to x square root 3, correct? We know that this side is equal to that. So what we need to do is a little bit of algebra here, and we're going to say, all right, 8 over square root 3 equals x. Okay? So I solve this. It looks like a nasty problem, which it is. It's not very nice looking. Okay, but we know that x, this side is 8 divided by square root 3, and if that makes you uncomfortable, I can maybe put it in a calculator, but understand that you'll get the same answer, and the number that I give right there is actually more accurate than any decimal you could put in this thing. But it comes out to about 4.62 if I round to the nearest hundredth. All right, and then also what I'm going to do here is I know that this is 2 times x, so I could take this and have 16 over square root 3, or which is equal to, and you can probably imagine what that's going to equal, which is 9.24. 9.24 round to the nearest hundredth. And obviously you could see that it's this doubled, right? Yeah, doubled. Okay, that's the way this works. And you could certainly check this with the Pythagorean theorem, which we'll do in class to make sure that it is correct. Okay, so I hope this video helped as a kind of a learning experience for you. Tomorrow, or the center quiz for this section, will be over just general Pythagorean theorem problems and also some application problems. So, but don't worry, application's okay. Have a great day, and I will see you in class.